Let's take next example. So what I will do now, I will make the next example. Instead of all this OH, instead of all this OH, I will write SH. S stands for sulfur. So I am going to, here I have written different configurations of this structure, that is pentane 2,4 diol. Pentane 2,4 diol. Now I am taking this compound where I have put sulfur in place of. I am not revealing its IUPAC name. You can try and tell in the comment section from your knowledge of IUPAC what will be named as. So now if I try to make different configurations and see, and what I will do, so let me, so I'm not drawing it separately. Let me draw it separately so that you will understand. This is, instead of oxygen I'm just putting sulfur there. That's the only change I am making. Let me draw the second. This hydrogen is towards me. Let me draw the third one. Third one again. S H, and this is H. And the fourth one is OH H, and here H, and here. So this time these are, we call A, B, C, and so this time you will appreciate that you do the same exercise of trying to find out the relationship. Only A and C will be changed. So A and C, if you try, they will not get superimposed. A and C, they are not superimposable on each other, but they are mirror image of each other, so that will be E. So here you got three different configurations, and here you got all are different. So every answer is same. Instead of identical, there will be relationship. In enantiomer, all other will be, all other answers will be same. So here you are getting four different configurations. So here you understand one important thing. See, this is one structural formula, this is another structure, this is one structure, this is another structure. If someone asks you, this is structure, These are the specific configurations. This is structure. If someone asks you which structural formula is more symmetrical, you will obviously say this structural formula is more symmetrical. Even though right now you are not aware of the elements of symmetry as well, but you can tell us which structural formula is more symmetrical. So this structural formula is more symmetrical, this structural formula is less symmetrical. So you will say the structural formula with 2 OH is more symmetrical, the structural formula with 1 OH and 1 SH is less symmetrical. So here is a concept. Is the symmetry of structural formula, is the symmetry of, or you can say symmetry in structural formula increases, number of possible configurational isomers, number of possible configurational isomers decreases. As the symmetry increases, number of possible configurational uh, isomers isomers decreases. So here is more symmetrical structure, so there are only 3 different configurations, and it is less symmetrical structure, so there are more different number of, as the symmetry in structural formula increases, number of isomers decreases. Similarly, you can, one related statement is the symmetry in the molecular formula increases, number of structural isomer, it is the symmetry of molecular formula increases, number of structural isomers decrease. That we will do when do the structural isomers. Okay, so that was the third example, and this was the fourth example. That was 3 and 4 are inherently related due to this important statement. So I related symmetry with number of isomers, but symmetry of molecular formula with number of structural isomers, and symmetry of structural formula with number of configurational isomers, or configurational isomers can be known as stereoisomers because they are part of the stereoisomer. Other part is conformational isomer. Both are differ by requirement of the energy. Okay, so I will discuss only this much in this video. Uh, let's meet in the next video. Thanks for listening.